we will start our investigation into the conic sections with the circle. So this is going to be nice because this might actually seem familiar from geometry already, but we're taking a quick dive into their equations, and more importantly, how to get their equations from the graphs with slightly more complicated examples than you might have seen in geometry. And we are going to have to rely on completing the square at some point. So if you haven't looked at the previous video and you have trouble completing the square, take a look at that previous video. Okay, so let's just remind ourselves what a circle is. So a circle is a set of points equidistant from some center point. So example, I'll draw it over here. You have the center point, which would be right there, but the circle itself would be maybe this purple thing, where let's say this distance is the radius, r. That distance is also the radius, this distance is the radius, and so on. Okay. But let's first even take it another step back and figure out how do we calculate the distance between 2 points. So in this example, I have the points -1, 2, so this one's somewhere around there, -1, 2. This point up here, 3, 8. And the question is, how far is this? So of course, when we mean distance, we mean the straight line distance from one to the other. So the way I'm going to break this down is, and I'm going to go kind of fast through this because this I think would be familiar to most of you. And break it down to a right triangle because we love when triangles are right. And because I have graph paper in theory, oh, I don't have graph paper here, but because I have graph paper and this would be on a graph or on a grid, you can make right angles easily. And so to get from -1, 2 to 3, 8, you could simply scooch over to the right and then go straight up. Form a right triangle and then use Pythagorean theorem. The question is, how long is this length? And similarly, how long is this length? This drawing is obviously not to scale, by the way. Okay, so if you remember how to figure out distance between two things, you can simply just subtract their coordinates and take the absolute value of it if it's not already positive. And so in this case, for my change in x, that would be 3 minus -1, which would be 4. And in my vertical distance, my y distance would be 8 minus 2, which is 6. And so in our Pythagorean theorem says that the distance itself is just simply 4 squared plus, or sorry, the square root of 4 squared plus 6 squared, which would be the square root of 52. Okay. So that hopefully was a nice refresher. And now the question is, how could I get the equation of a circle? So now let's pretend that we want to use that point 3, 8 as the center. Sorry, that's not the center. -1, 2 as the center, and then 3, 8 as a point on the circle. So that on its own already defines a circle. So let's draw a graph of this, or a sketch rather. So here's my point, -1, 2, that'll be my center. That's my center right there. And 3, 8, trying to draw this a little bit better to scale, might be somewhere up there. So this point right here is 3, 8. This is -1, 2. So we want to find the equation of this red circle right here. Okay, so this equation is obviously going to have some x's and y's in it. So let's just make up an xy. So let's pretend there's xy right here. xy. Now remember, because this distance is always going to be, sorry, the distance from the center to the circle is always going to be the same, that gives us a big hint as to what our equation would be. Sorry, someone came in the door. So I know already from the previous question that this distance right here is the square root of 52. Likewise, that must mean that this distance from -1, 2 to any point xy, I just happen to draw that one, is also the square root of 52. So let's see, how could I figure out the distance? Well, I know the distance is 52, but how would I actually calculate that would be to use Pythagorean theorem again, the distance formula. So I'll go over to the left and over and then up using a right triangle. So I know that the distance, and let's write this out, the distance from xy to, I guess it would be -1, 2 to xy. Let's say that to xy is root 52. Well, how did I use the distance formula? The distance formula was essentially the Pythagorean theorem. And so the square root, we know it's going to have to equal 52. The square root of the x distance, I'll say, x distance squared plus the y distance squared. Now, what is the x distance? We take a look back up here, here in green. I simply subtracted their coordinates. And so that x distance right there is going to be, well, x minus -1. So I'll write that in here right here. X minus -1. And similarly, their y distance, which I'll draw here in blue, was right here, which is going to be also y minus 2. And so our equation now is going to look like this. So y minus -1 is really, or sorry, x minus -1 is going to be x plus 1 really, squared, plus our y distance, or change in y, be y minus 2 squared. And that equals 52. And that really is going to be your equation of your circle. Let's clean this up a little bit, because usually all the square roots kind of make things nasty, and what we could easily do to just get rid of them is to square both sides. So if I square both sides here, so I'll just raise both sides to the second power, and I'll just have x plus 1 squared plus y minus 2 squared equals 52. 52. We can kind of see here where the different parts of the circle come from. So what's really important about the circle, or to define the circle? What you would really need to know is its center and its radius. So we can see here that in our final equation, which is here, let's make it pretty, let's put it in red. This 52, remember our radius was actually the square root of 52. So this 52 is actually r squared. Again, we just like to do that to get rid of the square roots on either side because they're unsightly. And where did this come from? Well, this being the plus 1 and the minus 2. If we take a look at this, that x plus 1, that's how you would determine x's distance from -1. And so, and likewise, minus y minus 2, that would tell you how far the difference in their y coordinates are. And so really, if I want to summarize the equation of a circle, I would have x minus, we usually also use h squared, plus y minus k squared equals r squared. Again, this is similar to the Pythagorean theorem, where this is a squared plus b squared equals c squared, really. And of course, what is the h and the k? So, and the r? R equals the radius, and this hk, that is your center. Notice here that because it was plus 1, it was actually really written as x minus -1. You might say, like, wait, that doesn't look like the equation of a conic section or a quadratic relation like we had mentioned in the first video of this unit, but it really is if I just multiply everything out. And so let's do that here. I have x plus 1 squared plus y minus 2 squared equals 52. And so if I just multiply everything out, then you'll see that it actually is. Let's see, I have x squared plus 2x plus 1 plus, so that's just the first parentheses, y squared minus 4y plus 4, and that would equal 52. If I want to move everything to the left side, I'll have x squared, and I could rearrange it in descending degree if I wanted to, plus y squared plus, let's see, 2x minus 4y, let's see, 1 plus 4 would be 5, and if I subtract 52 from both sides, I'll have minus 47, I believe, equals 0. And so that, you can see, is your, you could say, standard form of your conic section or your quadratic relation. And notice also here that there is no xy term, like I said before. So we could, if you want to write it in, the xy term is actually plus 0 xy.